and here's another one to have a go at. So again, we've got to split it up, and we've got to decide which bit is which, and the straight power of x, so that's going to be a u, and the other bit's going to be a v dash. And I've just written the integration by parts formula down here, so we don't lose it. So what are we going to do here? We're going to go u normals and dashes, v's normals and dashes. So u we think is going to be x squared, which differentiates to give us 2x, and v dash is going to be e to the 3x, which when we integrate that, it's going to give us 1/3 e to the 3x. Okay, and then it's just a matter of sticking all this back into, so we get u times v, which is this bit times this bit, x squared times 1/3 e to the 3x, minus the integral of u dash, which is 2x, times 1/3 e to the 3x. So what have I got? That bit I'll tighten up to x squared over 3 e to the 3x, minus, let's take that 2 and the third out the front, x e to the 3x dx. Okay, and when I look at that portion, I go, I still have to do this integral here, and that looks suspiciously to me like it's going to be an integration by parts. So I have to split this thing up into a u and a v dash, and just go through the process again. So do my second integration by parts. I now have u is just going to be x, which differentiates to 1. V is e to the 3x, which integrates to a third e to the 3x. And I'm left with the bit out the front here is still the same. I don't have to integrate that again. I've already finished that. Minus 2/3 of integral here is going to be u times v. So this bit times this bit. So x over 3 e to the 3x minus the integral of u dash times v, 1/3 e to the 3x dx. Which gives me, what have I got? X squared over 3e to the 3x minus this bit's already integrated, so I can deal with that. So it's going to be 4/9 x e to the 3x. 2 minus is going to make a plus. 2/3 and 1/3 is 2/9. Integral of e to the 3x is 1/3 e to the 3x plus c. Okay, so I've now finished all the integration. I don't have to worry about, because I can actually do this integration here. So let's just tidy this whole lot up a little bit. So I can take a third e to the 3x out the front. And what am I left with? Here I'm just going to be left with an x squared. Here I'm going to be left with a second third x out the front. I'm going to be left with 4/3 x, and here I'm going to be left with 2/9. Yep, and I think that's, hang on, have I got that right? How did I get a 4 there? That should have only a 2, shouldn't it? Yes, that should have only been a 2, and that should have been a 2/3. That's better. Okay, so the key thing is here that I had to do the integration by parts twice, effectively because each time I did it, I reduced the power here by 1, the degree by 1. So I started off with an x squared, and I differentiated, I was left with an x, which is still floating around in here, and I differentiated that again, it went away. So whatever that power is in there, in this case the power of 2, I had to go through the process twice to get it to work out.